Before delving into chemistry, there's something you have to note: the periodic table, which consists of over 118 elements. Every element is presented like this. Within a box, in the middle, is a letter or letters. This letter represents the element hydrogen, which is the first element in the periodic table. So this represents the symbol. Within the left-hand corner, there would be a number, which represents the atomic number. And within the right is another number that represents the mass of the element. Now, with these checked, we can really dive into what an atom is. To note what an atom is, it's basically the building block. The building block of absolutely everything. It is the building block of matter. And within this, it is consisted of three things. It is consisted of electrons, protons, and neutrons. These three compositions make up an atom. Now, to place differences between these three, the most important thing to note is their charges. An electron has a negative charge. Meanwhile, a proton has a positive charge. An easy way to remember how a proton has a positive charge is the P. P stands for positive. Although a neutron has no charge. Its charge always stays at 0. Another thing to note is their places. Where are they placed in a diagram? Well, the neutron is always in the nucleus. Proton is also within the nucleus. Both of the neutrons and protons stay together within the nucleus. Although the electron orbits around the nucleus, which is called the orbitals, which we'll talk about later. So just to imagine how this would quite look like, it's similar to this. So the neutrons and the protons would stay in the middle. This is called the nucleus. Around it, these circular rings are called orbitals. And on these orbitals would be the electrons. It would be placed in random orders. But to remember, when drawing a diagram, there are certain rules that you have to follow. And to note, this diagram was made by Bohr in 1913. If I was to use this diagram to draw the element, for example, the fourth element in the periodic table, which is beryllium, I can draw it out. So, by taking into consideration of the nucleus and orbits, the nucleus would be in the middle. This would consist of the neutrons and protons. Now, around this would be its orbits. And on the orbits would be the electrons. But to know exactly which electron goes where, you would have to follow the orbital rules, which are, within the first orbit, there can only be 2 electrons. So we'll follow that. Here's one electron, here's the second electron. And within the second orbit, and the third, and the fourth, and the fifth, and the sixth, depending on whatever element it is, there can only be 8. 8 is the limit. So for the first orbit, the limit is 2. The second, and larger, is 8. And another thing to really keep an eye on is places of each composition. So that includes the electrons, the protons, and the neutrons, which we've successfully done so far. And I have mentioned that beryllium, its atomic number is 4. I have only drawn 2 electrons on the diagram so far because I was following the rules, right? I was following the orbital rules that only 2 electrons can go within the first orbit. But there's 4 in total. Where do the other 2 electrons go? They simply go onto the second orbit, and they can be placed wherever you desire. And you don't simply have to do circles, you can do X's as well. So far we have followed the orbital rules, 2 electrons within the first orbit, and and the limit of 8 in the second orbit, which we have succeeded, and the places of each composition as well. The neutrons and the protons strictly stay within the nucleus, and the electrons orbit around them, which we have done. And that is that. Thank you for watching.